Hey there, Mr. Weaver here, and this is 8th grade, Module 6, Lesson 3, Solve Systems of Equations by Substitution. After this lesson, you need to be able to use substitution to solve a system of linear equations, including those that have zero or infinitely many solutions. Let's learn solving systems of equations by substitution. Substitution is an algebraic model that can be used to find the exact solution of a system of equations. It involves replacing one of the variables in one of the equations with an equivalent algebraic expression from the other equation in order to solve for one or more of the variables. What we're going to see in our examples with substitution is that if we do substitution correctly, the variable that we're substituting in for should disappear, and we should be left with the other variable and an equation where we can solve for that variable. Substitution is one of the other two methods that we can use to solve. We already saw graphing in a previous lesson. This method is helpful, especially when we're trying to find an exact solution, and graphing might just show us that they intersected at a place somewhere between the grid lines. So not quite always an easy way to get an exact solution. Well, this is. How substitution works. Here we can see some steps to solve the system of equations. We have y equals 4x minus 7 and y equals 2x plus 5. Let's use substitution. So first, with substitution, you have to get one of the variables alone on one side. So it's solved for one of the variables. Here, both of them are solved for y. So we are okay and we can continue on with substitution. Once one of them is solved for a variable, we can take what it's the same as. So if we look up here, we can see that y is the same as, that's equal to, 4x minus 7. So if we're doing substitution, instead of doing y in the second equation, I know that y is the same as 4x minus 7, so I can substitute that in. When I do that, I'm left with an equation with a variable on both sides, and then we can solve like we did in previous modules. So solving for x here, I can subtract 2x from both sides, it eliminates off of one side, and I'm left with 2x on the other. Adding 7 gets rid of it off of that left side. Add 7 to 5, I get 12. Finally, dividing to solve for x. If 2x is 12, then x must be 6. So by substituting, I can figure out one of the variables. Once I've figured out one of the variables, I'm going to substitute again to figure out the value of the other variable. So for this one, you can just pick either equation. Generally, I would pick the one that's easiest to solve for the other variable. Since they're both solved y equals, it doesn't really matter. Let's plug in 6 for x. 4 times 6 is 24, minus 7 is 17. So if x is 6, y must be 17. Last, let's double check that 6 and 17 work in the other equation. So we just figured this one out here by plugging it in for 4x minus 7. Let's see if 6 gives us an answer of 17 in the other equation. If I plug in 6 here, 6 times 2 is 12, plus 5 is 17. Since both equations ended up true, and I got 6 for x and y was 17, then the solution is 6, 17. Again, we write it as a coordinate. X is your first value, y is your second value. And those are the numbers that work in both equations at the same time. Example 1. Solve systems by substitution. Solve the system of equations by substitution. We have y equals x minus 3 and y equals 2x. So first, to solve this by substitution, we need to double check that either one or both of the equations are set where it's y equals or x equals. One of the variable is solved for. Here we have both of them as y equals, so we can proceed with substitution. Since y is the same as 2x in this bottom equation here, I can replace y with 2x in the other equation, y equals x minus 3. So doing that, instead of plugging in y, I have now 2x. Since they're the same, I can substitute them. Now to solve for my variable that's left, which is x, I can subtract an x off of both sides. 2x minus 1x is just equal to 1x, and I'm left with negative 3. So x is equal to negative 3. Now that I know that x is equal to negative 3, let's plug in negative 3 into either equation to find the value of y. So here they chose y equals x minus 3. If I plug in negative 3, I have negative 3 minus 3, I get negative 6. So if I plugged in negative 3 for x, I get out negative 6. We should double check that we get the same thing if we do with the other one, y equals 2x. If I plug in negative 3 for x, do I get negative 6 for y? 2 times negative 3 ends up being negative 6. So is that true? Yes. And here's a good instance where plugging it back into the other equation is pretty helpful for you to check your answer. Back in this original equation, if you had accidentally said negative 3 minus 3 was 0, which it's not, but had you accidentally said it was 0, when you go over to the other equation and you are plugging in negative 3 for x and 0 for y, do you get a true statement? Not anymore. You're now saying 0 is equal to negative 6. So that does not work. We can check our answer and know that 0 was not the right solution for y, since maybe we thought it worked over here, but it didn't work here. So we'd have to go back and double check. After all that, we find negative 3 and negative 6 is the coordinate for x and y that works in both equations. So that is the solution to this system of equations. Check your understanding. Solve this system of equations by substitution. Pause the video now and complete the check. Check your answer. You should have found negative 3 for x and negative 9 for y. If we're going through and solving this, I can either take negative 6 plus x and plug it in for y there, since it's the same as y, or I can take 3x and plug it in for y there, since 3x is also the same as y. Either way, I end up with negative 6 plus x on one side, and that is now equal to 3x based on substitution. So I can solve by subtracting x, and I get 2x, still have minus 6. Divide both sides by 2. X is equal to negative 3. Then if I plug it in, if x is negative 3, 3 times negative 3, I'm using this bottom equation here, 3 times x is y, so y is equal to that. 3 times negative 3, y was equal to negative 9. And I should double check in this top one. Since I used the bottom one here to figure out y, let's double check in the top one. Y is equal to negative 6 plus negative 3. If I add those together, I do get negative 9, which is what I got both times. And I already said that y was negative 9. That is true. So negative 3 for x, negative 9 for y. Let's learn. Rewrite equations to solve systems by substitution. Sometimes one or both equations in a system may not be written in slope-intercept form. When solving a system by substitution, one of the equations may need to be solved for either x or y in order for us to be able to use that substitution method. So we have to know what it's equal to in order to be able to substitute it in. So here we have an equation. We don't know what the other equation is, but let's just assume this is the easiest equation to rearrange and solve for x or y. We have 2x plus y equals negative 10. If we wanted to solve it for x, which we can do, we have not seen it done yet, but if x is easier to solve for, we can find what x is the same as and plug that in. Here I rewrote this so we can look at how to solve for each. To solve for x, I would first need to take away the y, since it's on the same side as the x. Then I have two x's. I only want x by itself, so divide everything by 2. And I end up with x equals 10 divided by 2 is 5, and it was negative. Y divided by 2 is the same as the 1/2 y. That one took a couple steps, but we were able to get the variable by itself. If we had solved for y, on the other hand, I can see that y is almost by itself already in the original equation. All I have to do is subtract off the x from both sides, and y is by itself, negative 10 minus 2x. So going forward, it's going to be helpful to look at what the equation looks like so you can figure out which one you want to solve for in order to use substitution. And going even farther into lesson 4, there's going to be a third method to solve these, and depending on what your original equations look like, Substitution might not even be your best option going forward. It might be the next method. So it's going to be really helpful for you if you're looking at what do the equations look like in order to decide what method will be best for you to use. Example 2. Rewrite one equation to solve systems by substitution. So solve the system of equations by substitution. We have y equals 3x plus 8 and 8x plus 4y equals 12. So in order to use substitution, one of the equations needs to be y equals or x equals, the variable solved by itself. Here we see y equals. We don't have to rearrange anything. We just have to use this one to substitute in. That's the one that tells us what our variable is the same as. So since y is the same as 3x plus 8, in our other equation where y is, we need to plug in 3x plus 8. So everything around it stays the same, except instead of y, it's now 3x plus 8, since that's what y was the same as. From there, we just need to solve. So let's distribute out. 4 times 3x is 12x, 4 times 8 is 32. Combine like terms. 8x plus 12x is 20x. I can subtract 32 from both sides. And I get negative 20. 20x equals negative 20, so x must be equal to negative 1. Just like before, once we figured out one variable, we need to replace that in to either equation. Here's another place where it's going to be useful to see how your equations are written. Since we solved for x, if I plug in x in the second one here, I would get negative 8, but then I have to go through and I'd have to add and then divide and so on. It's solvable, but it's not quite as easy if I had just plugged it in to the first one, since that tells us what y is equal to. It's 3 times x, add 8. So if we plug in negative 1 for x, 3 times negative 1 is negative 3, plus 8, we get 5. So the solution would be negative 1, 5. Let's double check with that other equation though real quick. I have 8x plus 4y equals 12. X is negative 1, so 8 times negative 1 is negative 8. Plus 4 times 5 is 20. Is that equal to 12? Negative 8 plus 20, or 20 minus 8, that is equal to 12. 12 equals 12. We have the correct combination of x and y that fits both equations. It is negative 1, positive 5. Check your understanding. Solve this system by substitution. Pause the video now and complete the check. Check your answer. You should have found that x was 2 and y is 8. So here we don't need to rearrange since we have y equals. That just means we take 6x minus 4 and we have to put it in place of y. So 2x plus 5, and then where y was, we now have 6x minus 4. That has to equal 44. Distribute out, I get 30 x's and minus 20. So 2x and 30x minus 20 is 44. Together, that's 32x. Add the 20 to get rid of it off of the left to both sides. I get 44 plus 20 is 64. 32 times what is 64, so x must be 2, just divide by 32. Once we know x is 2, y is equal to 6 times 2 minus 4. 12 minus 4 is 8, so y is 8. If we plug in y is 8 up here and x is 2 up here, do we get 44? 2 times 2 is 4, 5 times 8 is 40, 4 plus 40 is 44. So just double checking, my final solution 2, 8, x was 2, y was 8. Example 3. Rewrite both equations to solve systems by substitution. Solve the system of equations by substitution. We have y negative 3x equals negative 13, and 4x plus 5y equals 11. As I said in the previous example, it's going to be helpful for you to learn to see what the equations look like to decide which method is going to be easiest for you. Since neither of these equations are solved for the variable already, and both of them have x and y on the same side, with the constant number on the other side, substitution in fact is not your best method to solve. Elimination, which we'll learn about in the next lesson, would be easier to solve. But we still can solve by substitution with a little manipulation. This one has the y pretty much by itself already. All we have to do is add 3x to both sides, and we get y on its own with what it's equal to. Now, since y is the same as negative 13 plus 3x, let's replace y with what we just found. So negative 13 plus 3x, distribute it out, combine like terms, add 65 to each side, so we get our variable on the side by itself. We get 76. Divide both sides by 19, x is equal to 4. So once we rearrange to get a variable by itself, then everything from there is exactly as it was in the previous example. Now again, since we know x is 4, as we've been doing, let's plug it back in and see if we can figure out what y is. We can use either equation, or in fact, we decided when we rearranged that y was equal to negative 13 plus 3x. If we want to use this newly rearranged equation, we can, as another way to solve. But sometimes it's just easier to use what they gave you. So plug in 4, y minus 3 times 4 is 12, so y minus 12 is equal to negative 13. Adding 12 to both sides, I would find y is equal to negative 1. If I did 4 over here as well, I can still find y is equal to negative 1. So either way, in this system, x was equal to 4, y was equal to negative 1, so you should have wrote this coordinate. Check your understanding. Solve the system of equations by substitution. As a hint, look for the variable that is easiest to solve for and get by itself. Pause the video now and complete the check. Check your answer. For this one, you should have got 7 and negative 1. In this top equation, y is not the easiest thing to solve for. X is almost already by itself. I would just have to subtract 4y from both sides, and x is all alone. So after that, instead of plugging in for y like we've been doing, I'm going to plug in 3 minus 4y in for where x was. The rest is pretty much the same. Distribute out, I get 6 minus 8y. Take away 3 more y's equals 17. Combine like terms, I get negative 11y. Subtract 6, I get 11. Negative 11y equals 11, so y equals negative 1, which is what we got there. Notice we solved for y first. Y is the second number in the coordinate, so please make sure you put it in the correct spot. Then x plus 4 times negative 1, that equals 3. So x minus 4 equals 3, or x plus negative 4 equals 3. Something minus 4 is 3, so that something must be 7. Again, this second time I solved for x, I put it in the position where the x coordinate is. It goes x, then y. If you write them backwards, unfortunately, you did not choose the correct combination. Example 4. Solve systems with infinitely many solutions. Solve the system by substitution. We have y equals x plus 5 and 2y minus 2x equals 10. In the first equation, we can see y is the same as x plus 5, so let's replace that as we've been doing in for y for the second equation. Distribute it out, we get 2x plus 10 minus 2x. When we combine like terms, we have 2x minus 2x. Positive 2x minus 2x gives us 0 x's. It's gone. And we're left with 10 equals 10. When our variable was eliminated, we had two options. We have infinite solutions or we have no solution. If the equation is true, so in this case 10 equals 10, that means we have infinitely many solutions. These two lines are the same line, just written slightly different. If we were to graph them, one would be on top of the other. So in this one, we end up with a true statement at the end and no variable. There's an infinite number of solutions. Check your understanding. Solve the system by substitution. Pause the video now and complete the check. Check your answer. This has an infinite number of solutions. Here, x is solved, so I'm going to plug in for x. I have half of 2y plus 4. This was my x, so 2y plus 4 was the same as x. Plug it in. Minus y equals 2. Half of 2 is 1, so 1y. Half of 4 is 2. Take away y, and I get 2. Positive y minus y gives me 0 y's. I end up with 2 equals 2. My variable canceled out. I have a true statement. This was infinite solutions. Example 5. Solve systems with no solution. Solve the system of equation by substitution. We have x minus y equals negative 4, and we have x minus y equals 2/5. We can pick either of them to solve for x, or we could solve for y. It doesn't matter. Whichever is going to be easiest. So solving for x, I can just add y to both sides. I end up with x equals negative 4 plus y. Then, since we just found that x was equal to negative 4 plus y in the first equation, let's put it in the other equation. So negative 4 plus y minus y equals 2/5. When I do that, I get plus y and minus y. They make 0. I'm left with negative 4 equals 2/5. The variable canceled out. Did I end up with a true statement? This time I did not. So since that statement is not true and will never be true, there is no solution. If we were to graph these two lines, we would find that they are parallel and they do not ever cross. Check your understanding. Solve the system of equations by substitution. Based on the example, you should get no solution as your answer. So as you're going through this, see if you can figure out what happens to make no solution that answer. Pause the video now and complete the check. Check your answer. As I said, it has no solution. So let's see how we can get there. In these, I see both of them have y. That's positive. If I subtract 7x, I'm going to do it from the top one. I end up with it gone off the left. So I get y is the same as 9 minus 7x. When I plug it in, I'm going to put it in down here. 9 minus 7x. That was where my y was. Plus 7x equals negative 2. Why does this have no solution? Well, negative 7x and positive 7x make 0. I end up with 9 equals negative 2. So since my variables canceled out and it's not true, there is no solution. And if you wanted to check by graphing or using a graphing calculator such as Desmos, we could see that these are parallel.